Alrighty, we're gonna go ahead and get started here. Thank you all for being here today. I'm pretty excited to have all of you with us. Our field day is brought to you by the following people that work at or with the research center. We've got Alan Parrish, who's actually the director of all of our research farms with the University of Illinois. Then at the Northwestern Illinois Ag Research and Demonstration Center, we've got a research agronomist, Greg Steckel, who does a lot of work on the farm as well as Marty Johnson, who's we couldn't do what we do at the research center without Marty and Greg. And then there's me. I'm an extension educator, and I've been here for 1 year, and I am pretty lucky to have the resource of the research farm at my disposal out here. Here we go. And then, of course, I want to take a moment to thank the people that help keep the farm going as well. We've got the foundation that kind of helps make sure that we've got the land resources that we need to keep going. And then the companies and individuals from the companies that donate seed, chemical, fertilizer, and whatnot to the farm. We couldn't do what we do without them, so thank you. Today our presenter is Dr. Nick Seiter. He's a extension field crops entomologist with the University of Illinois, and he's going to talk to us about corn rootworm.
Hi, I'm Nick Seiter. I'm a field crop entomologist with the University of Illinois. I'm here today to talk about some of my rootworm research at the Monmouth Research Station. So I have here 3 roots that we took from our plots at Monmouth, brought back here to Urbana, and rated for rootworm damage. So what we're evaluating in this trial, we're looking at various BT trait packages for rootworm control. As most of you likely know, resistance to BT traits is something that we're very concerned about with the western corn rootworm in particular, and in recent years with the northern corn rootworm as well. And these 2 insects together make up the most economically important pest complex of corn in Illinois. What we look at here from these plots, we actually go and remove these roots from the ground. We have a whole power sprayer set up back here at Urbana. We clean all the soil off of these roots. We go through and look at them for damage, and you may be able to see here we have a fair amount of damage on this root. It's these pruned roots that we're looking for, whereas this root, relatively clean. What we had in here either did its job against these rootworms, or there simply weren't enough rootworm larvae in there to cause damage to that root. We have a rating system where we go through and actually quantify how much root damage has been done to these plants. We're looking for nodes of the root that have been pruned away, like this one here, to within 1.5 inches of the soil line of the plant. And this corn root's going to have 3 nodes on it, 3 different nodes of roots. And we rate them by the percentage of a node of roots that's been eaten away. So if we have an entire node of roots that's been pruned away by corn rootworm larvae, that would be a rating of 1.0. If we have 2 nodes that are pruned away, that would be a rating of 2.0. If we have 3 nodes pruned away, that would be a rating of 3.0. When we talk about our BT trait packages and our pyramided BT trait packages in particular, we're talking about unexpected damage. We're talking about a level of damage that might give us some concern about resistance development to these BT traits if we exceed a rating of 0.5. So if we lose more than half a node of roots in one of these pyramided trait packages, we're thinking there might be something up. That's something we want to take a second look at and see if we have resistance developing to these traits. So again, corn rootworm, that's our most important insect pest in Illinois, has been for many years. In recent years, we've seen lower populations of this insect than we did maybe 10, 15, 20 years ago before the advent of these BT trades. It's an insect that we're still very concerned with, something that can cause some pretty substantial damage if you let it go unchecked, if you have a damaging population and you let that go unchecked. As I mentioned earlier, in recent years we've seen an uptick in northern corn rootworm populations in northern Illinois, so that's an insect that we've been worried about in recent years as well. A couple of interesting things about northern corn rootworm. One, from day one when those BT traits were introduced, that insect was less susceptible to BT traits. Certainly the western corn rootworm, our more prevalent species in Illinois, was more susceptible to those traits on day one than the northern corn rootworm was. And we've actually had resistance confirmed in the northern corn rootworm now to two of the major traits that are out there, to Cry3BB1, that's the yield guard toxin, and Cry3435AB1, that's the old Herculex toxin, and those are the two toxins that are present in smart stacks. So resistance in the northern corn rootworm has been confirmed to both of those in North Dakota, and it's suspected elsewhere to our north. We have some suspicions that we might have some of that here as well, but that's not something we've been able to confirm yet. The other thing that's interesting about the northern corn rootworm is that it goes through an extended diapause. What that means is that right now, during this part of the season, those beetles are out there laying eggs. Most of those eggs in a normal population, in fact all of those eggs in a normal and a wild type population, are going to hatch next year, in year one, into presumably a cornfield. If they hatch into a soybean field, they're just simply going to die. With northern corn rootworm, a percentage of those eggs are going to hatch in year one, a percentage of those eggs will hatch in year two, and a percentage will hatch in year 3 and year 4, decreasing percentage at that point. But because of that trait, northern corn rootworm is actually able to overcome crop rotation as a control tactic. Now, western corn rootworm is able to overcome crop rotation in some parts of its distribution as well, but it does so differently. With western corn rootworm, they're actually going to lay their eggs in soybean fields in addition to corn fields. So all of those eggs with the western corn rootworm are still going to hatch in year one. But if they're laid in a soybean field that's rotated to corn, they'll survive. If they're laid in a soybean field that's continuous soybean, they'll die. If they're laid in a cornfield that's rotated to soybean, all of those eggs will die the following year. So that's how they've been able to overcome crop rotation as a control tactic. So there's a few things we want to be thinking about with corn rootworm this time of year, and we're talking getting into late July, early August. The first thing we want to do is what we've been doing in this trial, evaluating the effectiveness of whatever control tactic we've used, or if we chose to forego rootworm control this year, digging some roots from that field to verify that we made the correct decision, or if we made the incorrect decision in that, guiding our decisions for next year. So we want to go out and actually check out some roots, check out our fields now while the damage is still fresh, while you can still evaluate it, see how well we did, see if those trait packages are still performing how they're supposed to. If you used a soil insecticide, see whether that soil insecticide performed as it was supposed to. If you didn't use rootworm control, go out and see if they didn't eat your lunch a little bit. Go out and see if that was the correct decision for you. Verify that. It's important to keep in mind when we're looking at this rootworm damage, you'll see lodging if that damage is severe. You're not always going to see lodging. This root here had a pretty decent amount of damage on it. This plant's going to be suffering some yield loss from this damage, but it didn't lodge. You can see that here, the stalk is straight. We didn't have an issue with lodging. They're not always, just because you don't have lodging doesn't mean you don't have a problem. The other thing you want to do, and why you really want to check this out this time of year, you don't want to be finding that problem in the combine. You don't want to be finding that lodging at the end of the season where it might be too late, or you might not have the time to get out and confirm or verify that it was corn rootworm and not some other source of damage causing that. The other thing you want to be looking at this time of year in terms of your rootworm population is the adult numbers. And that's for two reasons. One, those adults do tend to stay in that cornfield that they came out of for at least the first 2 or 3 weeks after they've emerged. So getting a feel for how many adults you have in a field is going to give you an idea of whether or not you have some slippage on whatever control you're using. Two, and probably more importantly, if you're doing this to look at the effectiveness of your control, you really do want to go back in and check those roots out, check below ground and see what kind of damage you had. But two, we want to be thinking about next year. We want to know what's happening in that field this year to guide our decision making for next season. Get an idea of what sort of pressure you have. If you're scouting just plants, just whole count plants, we've got an economic threshold of 0.75 beetles per plant as the level that would say you need to make a controlled decision next year. If you're using what I would recommend, which is the yellow sticky card traps, whole lot easier to use those particular traps. We're looking at an economic threshold of 2 beetles per trap per day in continuous corn, and an economic threshold of 1.5 beetles per trap per day if you're looking at rotated corn. So if you're trapping in soybean this year to make a controlled decision in corn next year, if you've got about 10 or 11 beetles after 1 week of trapping in a soybean field, you need to be putting out some rootworm control if that field is going to be corn next year. So thank you all for listening, for participating here, and hearing more about the research that we're doing at the Monmouth Research Station. Great, perfect. Well, thank you for having me today. Thank you all for participating. Really appreciate the opportunity to share our results with you, share some management recommendations with you. Hate that I don't get to see you all in person this year. I'll look forward to hopefully seeing you all in person about this time next year at the field day. But it's a nice time to be talking about corn rootworm management, a good time in the season to be talking about that. And if you have one takeaway from what I'm talking about here with you today, it's to go out, particularly here in the remainder of August, and check your fields, see what you've got going on in your fields, both in terms of rootworm damage and in terms of adult populations. As I mentioned in the video, thinking back to 2020, to planting time in 2020 in terms of did what we do for rootworm control this year work? And thinking ahead to 2021 and thinking about both, do I need a control next year? And if I do put out a control, what should I use? And should I do something differently? So as you know, I've been talking for several years, and all my colleagues throughout the Midwest have been talking for several years about the development of resistance to Bt toxins in the corn rootworm. And we know that resistance is out there. We know it's out there in Illinois. It's out there in Illinois to all of the Bt traits that we have available to us right now for corn rootworm control. What we don't have a great handle on is where that resistance is located, where we have resistance to a particular trait. We know it's fairly widespread. We don't have the opportunity with corn rootworm like we do with weeds, for instance, when we have herbicide resistance, to see all of that damage. With rootworm in particular, the damage is occurring below ground. It's pretty easy to miss it if you don't go out and look for it. And in particular, it's really easy to miss that damage that's right around that threshold I talked about, that threshold of unexpected damage in a pyramided Bt hybrid, which is half of a node pruned away. When you have half of a node pruned away, if you get sufficient rainfall, if you don't get that plant knocked over by the wind, you might not see it above ground. You might not know anything's going on if you don't go out there and dig that root up and look at that pruning directly. And so that hampers our ability to detect this resistance. The other major challenge that we have with corn rootworm there's no exterior, no external sign if I pick up a corn rootworm beetle that tells me, yeah, this beetle is resistant, or no, it's not. We don't have a molecular marker the way we do with some of the weeds with water hemp, for instance, where we can take it into a lab and grind it up, test the DNA and say, yeah, this beetle is resistant, or no, it's not. We simply aren't there yet. For us to determine if a population is resistant, we have to observe that damage out in the field. We have to collect that population, rear out those eggs, and the following spring expose those larvae to the plants directly, to those BT plants directly. My colleague in the Illinois Natural History Survey, Dr. Joe Spencer, he was just up at Monmouth actually yesterday collecting beetles to do just that, so that we can get more of a definitive answer of what the beetles in that area are like in terms of their resistance status. We're going to do collections like that throughout the state. We're hoping to go over to DeKalb tomorrow, possibly to Freeport here by the end of the week. Going to check some populations in southern Illinois as well, just to see what we have out there. But really the best way to know what's going on your farm and in the trait packages that you're using is to go out and do some of these evaluations, see what your adult population is like, see more importantly what your root damage is like, and get a feel for how those different packages are performing on your farm. In terms of the population that we're seeing this year, the general trend is for higher beetle populations in 2020 than we've seen at least for the last 2 or 3 years in Illinois. And just seems to be a little bit worse the further north you go. It's not limited to northern Illinois. We've actually picked up a few sort of unusually high populations in continuous corn in southern Illinois this year. But there's more rootworm activity going on in 2020 than we've seen over the last few years. And that's become more and more apparent over the last 3 weeks since I filmed that video that you saw earlier. We're having more of an issue this year. So it's, again, a great time to be on the lookout for these two pests. Of course, both of them, I think, very familiar to you. The western corn rootworm, yellow, typically with those black markings on the hind wings. Northern corn rootworm without the markings and with an overall tan or green coloration, green, as you see here. In terms of what you're looking for, when you start to see drought type conditions in a field that really shouldn't be suffering drought stress, of course, that's a great indication. We all know what the lodging looks like after all the storms we've had this year. I'm sure we all know what root lodging and goosenecking look like. But again, the proof is in the pudding. The proof is in digging up those roots, cleaning the soil off of them, and seeing how much of this pruning that you have. And what we're looking for, you see this root here, it hasn't developed all the way. You get that discoloration, the darkened area. On some of these, if you're able to look a little bit closer, you'll actually see some tunneling where that rootworm larva kind of wore out a channel in that little rootlet. That's what you're looking for. If you were to feel the tip of this root, it would actually be somewhat sharp, as opposed to if you break it off mechanically while you're digging that root up, you won't have that discoloration and you'll have sort of a soft, squishy area there where you broke that root. That's what we're looking for. That's what we want to see in terms of evaluating how much damage that we've had. Now I'll share with you fairly quickly the results from these trials that we were looking at that I was discussing in the video earlier. Now, if you're familiar with the rootworm rating scale, it's on a 0 to 3 node injury scale. We look at those first 3 nodes of the plant, the ones that are below ground. We don't look at nodes 4 and nodes 5, the brace roots. But if you're familiar with these trials, how these trials go, having a rating of 0.5 in these non-BT controls, we don't really get too worked up about that. That's pretty low pressure for a rootworm trial where we've tried to artificially increase the population of the beetles out there. Typically we want to see those ratings up at least around a 1.0 in our untreated plots. What's concerning to me is that in a field where we don't have all that much pruning in the non-BT, we're up around a 0.3 in these pyramided BT trait packages. Numerically, we should not have that high of a damage rating in those pyramided trait packages when the overall pressure is this low. The second trial that we performed in that same field, we saw very similar results again, and in some of these single trait packages, for instance, we know the single trait packages aren't going to perform well anymore. We're not selling those in Illinois anymore. If you find that somebody is selling them, if you put out a single trait BT package for corn rootworm, that's not something that you should trust by itself for corn rootworm control. But what's concerning to me, again, is in a trial where we didn't, frankly, have that much pressure in our non-BT, we still got some decent pruning in these pyramided trait packages, a lot more than we're used to seeing, a lot more, for instance, than we saw in a very similar trial last year on the same farm. So that's something that concerns us, and we'll be, of course, very interested to see what we find in terms of our bioassays, in terms of our insect resistance bioassays from those populations at Monmouth and from those other populations in northern Illinois. But again, if there's a take home for you from this presentation this year, now is the time to be going out and evaluating how well you did. And in terms of evaluating your effectiveness, I demonstrated this in the video. We talked about that level of half of one node pruned away as your unexpected damage. And we talked about the economic thresholds for yellow sticky cards. So if you're averaging, if you put out those sticky cards, you're averaging more than 14 beetles per week in corn, that's 2 per trap per day, or 10 beetles per trap per week in soybean that's going to be rotated to corn, 1.5 beetles per trap per day, you really need to be putting out rootworm control next year. And again, if you have more than half of one node pruned away in your pyramided BT trait packages, you need to be hopefully reporting that, but thinking about doing something different for next year in terms of rootworm control. And by the way, in terms of mitigation strategies, the best thing you can do if you think you have a problem field, if you think you have a problem with rootworm resistance, is to rotate that field to soybean next year. There's no such thing as rotating effective BT traits anymore for rootworm in corn. You know, you really want to go out of corn in that field if you can next year. There's nothing better for that resistant rootworm population than killing them all or killing many of them by planting that field to soybean next spring. And no matter how much of a rotation resistant population you have, remember that that rotation resistance comes from the adults. Those larvae, if they hatch into soybean, they're still going to die. So just keep that in your mind, keep that in your back pocket in terms of a resistance mitigation strategy. But when we look at that pruning, again, I did want to provide you a little bit more of a close-up. Got a nice clear root over here. You can see, I think that 1, 2, 3 nodes of roots in there. That's what we're talking about. That half a node pruned would be half of your rootlets on one of those nodes looking like this, where within 1.5 inches of the soil line, you no longer have effective root tissue. So that's what you're looking for when you go out and evaluate these. Just keep in mind, again, it's not always going to look like this. It's not always going to be a situation where you don't have any effective roots left. And in fact, it's often a little more like what we're seeing in this picture on your right in terms of rootworm damage. As far as some other insect pests to keep in mind, this soybean gall midge, that's again it's a new pest of soybean out in Nebraska and Iowa, not just new to the United States, but new to science. They just recently discovered this. Still not present in Illinois, still something that we're on the lookout for. We've actually been conducting a survey for this in Illinois this year, and we're 0 for, I believe we've done 10 or 11 or more counties and haven't been able to find it, which is fantastic. We don't want to find it. We want to let it stay in Nebraska and Iowa long enough that they get the management strategies worked out, and we can learn from what they've had to deal with that. But something to keep an eye out on there. And the first symptom you would have for this particular insect would be early dieback of those plants. Be located primarily along the edge. And if you go to an edge, you've got a lot of early dieback. You peel back the skin of that plant, you open up that stem, and you'll find these tiny orange maggots, these tiny orange fly larvae. If you find anything like that, please give me a call. Give Chelsea a call, give somebody a call and report that. It's something we want to be vigilant for. And if it does end up in Illinois, we want to know about it as soon as possible so that we can start doing something about it. And soybean aphid, I thought I would put this in there. That activity continues to be pretty minimal. We're not hardly seeing them, even up in northern Illinois. If you happen to come into some issues with soybean aphid, certainly let me know, but that hasn't been much of an issue for us this last year. And our defoliators through most of the state, with the exception of a little bit of green cloverworm activity in some spots, our defoliators have been fairly mild this year as well. Corn rootworm's been the major one this season, as it typically is in Illinois. And that's one I'd really, in terms of management issues to focus on, especially for the remainder of August here, be evaluating those cornfields and determining what sort of a population you have so that you can make your plans for next year. With that, wanted to put up my contact information here. Please don't hesitate to give me a call, shoot me a text, shoot me an email. If you see anything, if you have any questions, if you're interested in what's going on in the field. Also wanted to share this link with you. This is our Crop Central Field Crop Production Resources. You have the link there available for you. That's where we're going to be posting all of our articles, our fact sheets, our videos, the production resources that we're putting together to help you all manage your crops, and hope you all to answer insect management questions, disease management, agronomy, everything we've got out there, we're going to try to put up there. So with that, thank you for your time, and be really happy to take any questions that you may have.
But there is a question here in the chat box, Nick. Getting any calls on whiteflies? I am seeing them in about every bean field, but nothing in big numbers.
Yeah, so I've heard one or two reports on whiteflies. The story with whiteflies, they're one of those pests that in soybean, it can theoretically be a pest. Like it happens. It's pretty doggone rare for it to happen. And when you've got whiteflies as a damaging issue, you're going to know it, because that field's going to be like soaked with their honeydew. It would be kind of like, think of soybean aphid in the heyday, where it's just everywhere. So it's not something, when you're seeing a few of them here and there, you see that almost every time you have either a very dense canopy with high humidity or a lot of moisture. Very common to see them in soybean, but incredibly rare to see them at damaging levels. And in fact, I've never walked a field where whiteflies were at any sort of an economic level. If you ever do find that, I would love to walk a field like that, but typically it's not something that we worry about too much in soybean, unless you're growing them in a greenhouse. The question is, any particular thoughts on why we're seeing higher corn rootworm levels this year in the Midwest? Good spring for survival with a question mark. I would say yes, that's part of it. And especially when we look up into northern Illinois, when you avoid those flooding conditions, those saturated soil conditions during egg hatch, that does help those larvae to survive better. We got a couple of more nice saturating floods here saturating rain events here in Urbana, right around egg hatch, that probably didn't help our populations any down here. That is part of it. I do suspect part of it, just over time, is just a continued loss of susceptibility to the BT traits that we have. Every year that declines a little bit, we're going to get a little bit more adult survival. And finally, there has been, over the last
few years, especially because of commodity prices, more non-BT corn that's gone out. So all of those factors together, you do see an increase in the adults. But what really concerns me is when we see some of these high populations in fields that have a pyramided trait package. That's what sort of opens my eyes up, and that's what concerns me a little more than even just increased pressure. And certainly our higher numbers that we have this year, that's not to say that our numbers have gone back to, say, 2007, 2008 levels. They haven't. You know, we're not back there yet, but we are higher than we've been over the last couple of years. And yeah, environmental conditions and continued loss of susceptibility and use of more alternative varieties, alternative controls, all are going to play a factor in that, play a role in that.